Chapter 1, Trigonometric Functions, talking about angles. A counterclockwise rotation. So a clockwise rotation that is going this way, counterclockwise, generates a positive measure. And a clockwise rotation, so one going this way, generates a negative measure. Going back to geometry, we have complement and supplement of an angle. Complement, or complementary angles, add to 90 degrees. Supplementary angles add to 180 degrees. So find the measure of A, the complement, and B, the supplement of an angle measuring 40 degrees. So in order to find the complement, we're going to subtract 40 from 90, and that will give us 50. And then to find the supplement, we're going to subtract 40 from 180, and that'll give us 140 degrees. Your reflect question: for any angle, by how many degrees does its supplement differ from its complement? That would be 90 degrees. Finding the measures of complementary and supplementary angles. So the little square means 90 degrees. So we're going to say 6x plus 3x equals 90. That's going to give me 9x equals 90, which will then give me x equals 10. Plugging that in, 6 times 10 is 60 degrees, and 3 times 10 is 30 degrees. Same thing here. This is going to give me my half circle, which is 180 degrees. 4x plus 6x equals 180. 10x equals 180. X equals 18. Plugging that in, 4 times 18 is 72 degrees. 6 times 18 is 108 degrees. Calculating with degrees, minutes, seconds. I like to say, think of a degree as an hour. So in 1 degree, there is 60 minutes. In 1 minute, there are 60 seconds. The 1 tick mark means minute. 2 tick marks means seconds. When you go to atom, line up your minutes, line up your seconds. So I'm going to say 51 degrees, 29 minutes, plus 32 degrees, 46 minutes. You go to add these, I'm going to get 75 minutes, and I'm going to get 83 degrees. Now 75 minutes, we don't hardly ever say 75 minutes. Instead, we can simplify that to be 1 degree, 15 minutes. And when we do that, we're technically going to add that 1 degree to the 83. So that'd be 84 degrees. And we have that 15 minutes left. So that is your answer there. When you go to subtract, 90 degrees minus 73 degrees, 12 minutes, you notice that there are no minutes here in order to subtract. But I can rewrite 90 degrees to be 89 degrees, 60 minutes. That will then give me minutes in my minutes column. So I'm going to say 89 degrees, 60 minutes, minus 73 degrees, 12 minutes. When I go to subtract those, I will have 48 minutes and 16 degrees. So 16 degrees, 48 minutes. How many seconds are in 1 minute? We know that. There are 60 in a minute, 60 seconds in 1 minute. And then in 1 degree, like I said, think of degree like an hour. 60 seconds in a minute, 60 minutes in an hour, 60 times 60. There's 3,600 seconds in 1 degree. When we go to convert between angle measures. So degrees, minutes, seconds are used in longitude and latitude. They give you a point on the globe. It can also be referred to as a decimal degree. So we can convert degrees, minutes, seconds to decimal degrees. In order to do that, we are going to keep the whole number. So keep the degree. You're going to take the minutes and divide by 60. Divide by 60. And then you're going to take those seconds. You're going to divide by 3,600. Once you do that, you're going to add it all together. So I'm going to say, I'm going to keep my degree, 74 degrees. I'm going to add. I'm going to take that 8 minutes and divide it by 60. And then I'm going to take that 14 seconds and divide it by 3,600. When you go to do this on the calculator, be sure to use parentheses. I'm going to say 74 plus parenthesis 8 divided by 60. Plus 14, parenthesis, 14 divided by 3,600. When I do that, I'll have 74.137 degrees. When we go to convert backwards, keep the whole number. So we're converting decimal degrees back to degrees, minutes, seconds. So you're going to keep the whole number. Multiply the decimal by 60. And then repeat if you get another decimal. So I'm going to keep the whole number. I'm going to say 34. That's going to become my degree. I am then going to take the 0.817 times 60. Do that on the calculator. 0.817 times 60. That's going to give me 49.02. So I still have a decimal. I'm not done. 49, I'm going to keep. That's going to become my minutes. I'm going to take the 0.02 times 60. 0.02 times 60. I get 1.2. Now, since I'm converting to degrees, minutes, seconds, once I'm here, I don't have to multiply that decimal again. However, if your 2 is 5 or above, you would round up. So the 1 becomes my seconds, since I do not have to round. So 34 degrees, 49 minutes, 1 second. An angle in standard position an angle is in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. So if its vertex is at the origin, and this is going to be the initial side. Okay. The figures show ranges of angles measured for each quadrant when 0 degrees is less than theta. It's just a Greek letter, Theta. Theta, just like x. X and theta are the same thing. Angles in standard position whose terminal side, so now we have vertex, initial side, and then you're going to have your terminal side is the one that moves. So this is my terminal side. Angles in standard position whose terminal side lie on the x-axis or the y-axis, such as angles with measures 90 degrees, 180 degrees, and so on, are quadrantal angles. So anything that your terminal side lays here, 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 or even here is a quadrantal angle because your terminal side lies on the line. Coterminal angles, angle measures with 60 degrees and 420 degrees. So if I had an angle that looked like this, and we'll say that that is 60 degrees. And I also had an angle that looked like that. But have the same initial side and the same terminal side, but different amounts of rotation. So 60 degrees, and then if I go around and come back and stop right there, I went a full 360 degrees plus another 60. So I went 420 degrees. Such angles are coterminal angles, and their measures differ by multiples of 360 degrees. So if it's greater than, if your number is greater than 360, we're going to subtract. So I'm going to say 908. How many times do I have to subtract 360 to get that between 0 and 360? Because I want the least positive measure. 908 minus 360. And I'm going to have to subtract that at least twice. So 908 minus 720 then gives me 188 degrees. If it's less than 0, I'm going to have to add 360. So negative 75, I just have to add 360 once. That's going to give me 285 degrees. Negative 800, still less than 0. I'm going to have to add 360. Negative 800 degrees plus 360. And I'm going to have to add that at least 3 times. So negative 800 plus 1080 is going to give me 280 degrees. And that's how you find the coterminal angle. Last but not least, we have a word problem. A constant angular velocity disk spins a disk at a constant speed. Suppose a disk makes 480 revolutions per minute. Through how many degrees? So my final answer has to equal degrees. Will a point on the edge of the disk move in 2 seconds? So I want to know how many degrees that's going to spin in 2 seconds. First thing I notice is that my times are different. I have minutes here, seconds here. So I want to go ahead and convert that. In 1 minute, there are 60 seconds. So now my times match. I also notice that I have revolutions and I need degrees. So in 1 revolution, in 1 spin, 1 revolution, I'm going 360 degrees. I'm going for a total of 2 seconds. So now watch what happens with your units. Revolutions cancel, minutes cancel, and seconds cancel. I am left with just a degree mark, and that's what I want. So I'm going to take 480 times 360 times 2, and I'm going to divide that by 60. And when I do that, I get 5,760 degrees.
So kids, if you report to my office.